I think you should be able to type in the comment now. Okay, very good. And then can you also see my screen? I'm going to be writing something now. So I need to confirm that you can see my screen properly. Okay. I'm going to write something on the screen. So I'm going to confirm that you can see my screen properly. So I will uh simple harmonic motion. So can you see the screen? Like, can you see what I wrote on the screen properly? You guys are no longer here. What's up? Okay. I'm seeing only one person here. Why is that so? I mean, six people voted for this time. So I'm expecting to see everybody. Please let me alert your colleagues on the WhatsApp page. Tell them that I'm starting the class already because if they're not turning up, uh, I will not. Okay, I think I have three of you already because by 7, I will need to leave this place. So let me start something. Now, if there's any problem along the way, maybe you cannot hear me properly, just always type it in the comments so that I will not just be speaking alone. And make sure you alert your colleagues to join as well. So quickly, let me start with simple harmonic motion. By definition, simple harmonic motion is basically a type of motion that is periodic in nature. And when you hear the word periodic, periodic means that it is repetitive, it is repeating itself. So that's the first thing you must know about simple harmonic motion. Simple harmonic motion is a periodic motion, it is repetitive. And since it is repetitive, it also has a pattern that it follows. The pattern it follows is that there is always a fixed point. So simple harmonic motion is a periodic motion about a fixed point. This fixed point is known as its equilibrium point or its center. You can loosely call it its center. Its simple harmonic motion is a periodic motion about a fixed point, such that the acceleration of that body, acceleration A, is proportional to the displacement. Acceleration is proportional to the displacement. But not only that, the acceleration is in opposite direction to the displacement. So, which is why we will have a negative sign here. So, this is the basic definition of simple harmonic motion. Simple harmonic motion is simply the what? The periodic motion of a body about a fixed point. This fixed point can also be called the equilibrium point or its center. And the acceleration of this body is proportional to the displacement, and it is in opposite direction as the displacement. So this thing I just wrote here now gives a perfect definition for what simple harmonic motion is. A represents the acceleration and X represents the displacement. And from this place, this is where I will really start the whole motion thing with. Now, we realize that whenever you have constant of whenever you have the proportionality sign, you can introduce equation into it. So this will be A will then be equal to. Now, when you introduce equal to sign, there must be a constant of proportionality. Don't forget, initially, what we had there was negative x. So the constant of proportionality that will be introduced in is omega squared. A is what? Omega squared. And then, so when you do that very well, so you have A equals minus omega squared x. And this equation is the general equation of a body in simple harmonic motion. This is the general equation of a body in simple harmonic motion. A is the acceleration. A is the acceleration. X is the displacement. And this omega, which I will quickly talk about it now, the omega is the angular speed. Sometimes some people call it angular velocity. So omega is the angular speed. So this equation is the general equation of a body in simple harmonic motion. Now, quickly, let me do a little bit play around this omega before I move forward. Now, if you remember very well, the average speed is always what? Is always distance or distance over what? Over time. Average speed is distance over time. Now, in the case of simple harmonic motion, because it is an angular kind of motion, so instead of us using this linear speed, we tend to use what we call angular speed, which is omega. And then, since speed is distance over time, angular speed will now correspond to what we call angular displacement. In this angular displacement, we always represent it with theta over what? Over time. So what does that tell us is that what? Omega equals theta divided by time. Now, quick one. I want to test. So I will be asking some question. I will want you to be placing it in the comments section. When we say something is periodic, if something should undergo one period, something is periodic in nature, like circular motion now. If something should start from here and move in a circular path and come back to this place, how much angle do you think it would have covered? What would be the angle covered when you moved round a circle once? What would be the angle? So I'm waiting for your comment. What would be the angle if a body should move in a circular path and then they moved in one cycle? What would be the angle that they would have turned? In case you don't know, just tell me that you don't know. So, but don't keep mute in the comment section. What will be the angle turned if somebody moves in a complete cycle? What angle would they have turned? So please uh, drop the answer in the comments. I need to make sure that you are following. And in case you don't know, just tell me that you don't know so that I can proceed and tell you what it is. Are you guys the A like this? It seems you guys are not A. I'm not getting response from anybody. What would be the angle turned if somebody should move in a circular path? What would be the angle turned if somebody should move in a circular path? You people should stay online though. I need to leave this place by 7 on the dot. Oh. Hello, you guys moving up and down. I asked a question and I'm waiting for you guys to drop the answer in the comments. So if somebody turned a circle, Okay, so I asked a question. If somebody should move round a circle, if somebody should move around a circle, so this is my question. If somebody should start, let's say from somewhere here, and they moved around a circle, how much angle would they have turned? How much angle would that be? Oh, okay, okay. You don't know. When you move around a circle, you are said to have turned an angle of 360 degrees. So you have moved an angle of 360 degrees when you turn in a full cycle. And you see, this full cycle is known as a period. The time it takes for you to cover a full cycle is known as what? Period. So, period with capital letter T is a time taken to complete one cycle. Period is the time taken to complete one cycle. Now, from here, we have been able to establish that if somebody should complete a cycle, the angle they would have turned would be 360 degrees. And this angle now in degrees, we can convert it to radians. We can convert it to radians. In radians, please be taking note of all these things. I will still send the link of the video later. In radians, pi rad is denoted as 180 degrees. That is, anytime you have what we call pi rad, that means that you have turned an angle of 180 degrees. Now, what do you now think will happen if I've turned an angle of 360 degrees? How many pi rad do you think that would be? I think you should be able to figure that out. So how many, if I've turned an angle of, if let's say one pi rad is 180 degrees, how much rad do you think I would have turned if I turn 360 degrees? Just look at the relationship. So if 180 degrees become 360 degrees, what will pi rad become? What is happening to 180 degrees to become 360 degrees? So what will happen to pi rad in that situation? I don't like the way you guys are not engaging. Anyways, because of time, I'm going to proceed. So if 180 degrees is pi rad, then it implies that 360 degree is the double of 180 degrees. So that means that if 180 degrees is pi rad, then 360 degrees will be 2 pi rad. 360 degrees will be 2 pi rad. Now, where am I going with all of this thing I'm doing? I'm trying to explain that when somebody moves in a full cycle, the angle they have turned is 360 degrees. Now, if the angle they have turned in 360 is 360 degrees, in radian, we say they have turned 2 pi radians, 2 pi radians. And since this is a full cycle, the time it takes to cover a full cycle is known as period. So when we come back to this formula, omega equals angular displacement over time. So omega can then be rewritten as theta is the angular displacement. So if the angular displacement is 360 degrees, that is 2 pi what? 2 pi. Then the time in that situation is known as the period. Is known as the period. So one of the relationships that we'll be using in this simple harmonic motion is the fact that omega, which is the angular speed, is always going to be 2 pi divided by period. Omega is always going to be 2 pi divided by the period. And I want you to take note of this particular equation because I'm going to be using it very well. So I started from the fact that the general equation of simple harmonic motion, this is it right here. Acceleration proportional to displacement, and they are in opposite direction. This omega is the angular speed. Then I proceed to explain something about distance over time and all of that. Then another thing about the velocity, the linear velocity of a body moving in simple harmonic motion. is given as omega square root of a squared minus a squared minus x squared. Now, a in this place is known as the amplitude. A is known as the amplitude. What is amplitude? Amplitude is maximum displacement. Amplitude is maximum displacement. And the way I'm not able to like properly follow you guys up very well because I'm not seeing your comments and all of that. So it's I'm not able to flow with the class and I don't know which one you are following. I don't know which one you're not following. So, but anyways, because of time, let me. Okay, I have just 7 minutes more. Let me touch. Don't forget, I told you that I will actually still touch this topic in full process. Like I will take it step by step. So this is just like for the trial class. Now, the what's it called? In simple harmonic motion, we have these different types of motion that we deal with. We have the simple pendulum, we have the helical spring, and the likes. So let me start with the simple pendulum. So how do we analyze the motion of the simple pendulum? So for the simple pendulum, this is how it looks like. So if you swing it, you're going to have something of this nature. Yeah, so this is the simple pendulum. Okay, okay. So this is the simple pendulum. Now, I want to quickly show you something here. You see, for this simple pendulum, we need to note the acceleration. As you can see, it is hanging downward. Because it is hanging downward, therefore, its acceleration is going to be g, acceleration due to gravity. The acceleration is going to be g, which is acceleration due to gravity because it is hanging downward. And also, what about its displacement? Its displacement from the fixed point. Don't forget the definition I gave you earlier. This is the fixed point. This is where the motion is occurring. Its displacement x is going to be the length of this guy. It's going to be the length of this guy. So what do we want to do with that? You remember our equation earlier? Our equation a equals minus omega squared x. So if I bring that equation here again and I say a equals minus omega squared x. So what is a this time around? Our a is g minus omega squared. What is x this time around? X is what? X is L in this situation. Now I'm going to be ignoring the negative sign now because that is just showing the direction. So I'm not going to be using it in this place. So if I solve for omega in this place, you see that g over L equals omega squared. What does that imply? You can find the square root of both sides. So omega will then be square root of what? G over L. You have been able to solve for omega. The angular speed for a simple pendulum is the square root of what? G over L. Now, another thing again I have earlier is that I was able to solve this. Omega is 2 pi divided by what? Divided by period. So if omega is 2 pi divided by period, so that means that I can equate this thing to 2 pi over what? Over period. So if I cross multiply so that I can solve for period, that means that I will have what? T times square root of g equals 2 pi square root of L. If I divide both sides by square root of g, so what you notice here is that our period is going to be what? 2 pi square root of what? L over G. And that is how the period of a simple pendulum is derived. This is the period of a simple pendulum. L is the length of the pendulum and G is acceleration due to gravity. Also, similarly, frequency is the inverse of period. So if frequency is the inverse of period, that would just be the inverse of 2 pi square root of L over G, which will then result into 1 over 2 pi square root of G over L. So this is the period here. This is the period of a simple pendulum, and this is the frequency of a body in simple pendulum. So you can see that the period is depending on two things: the length of the of the pendulum, and g, acceleration due to gravity. It does not matter how heavy, that is the mass of this pendulum. The mass of this pendulum does not matter. So that is what we can see from this place. So basically, oh, I've asked that question since somebody is just commenting now. So basically, this is more like a summary. This is not a detailed lecture on simple harmonic motion. I'm still going to be sharing this link so that those of you that missed the class, you will be able to catch up with the class later. You can watch the video later, but it's like 7 already. So, and I have to go. Like this class cannot last beyond 30 minutes. So this is what will happen. I'm going to send the link. I'm also going to try to screenshot and send the notes to you guys as well. And I want you to, so I will drop the further update on the WhatsApp. But the way you guys turned up this evening, I'm not really that impressed because some of you did not join the class earlier and all of that. And so this is going to be a serious business if you really, really mean it, if you want to join. I'm going to be starting the topic from the beginning, everything from the basics. I will teach you from fundamental quantities. I will teach you scalar and vector. I will start motion from linear motion, not from simple harmonic motion. This simple harmonic motion is just a sample test. I will still teach it later in depth. So uh, I'm going to be going off now. So I will send you the link to the class later. All right.